Hello, this is Pete Cachopi, and I'd like to give you a brief talk today about prescriptive analytics with Python. So first, let's summarize some of the advantages of the Python language. Uh, the most obvious advantage is that Python is the most popular scripting language in the world. So scripting languages have an inherent advantage in that they're interactive, which promotes a faster learning cycle. With a scripting language, you can use an interactive shell to write small programs or just to write one-line programs. And this sort of quick feedback loop makes learning a lot easier. With Python, you get to combine that with a huge online community that has a massive set of teaching resources online. So you have a great many online courses to learn Python, but most importantly, I think, and this is an area where Python really shines, Python outstrips all of the other scripting languages in terms of the depth and the breadth of the answers that are available with Google searches. So you can verify this for yourself. If you start Googling up questions about Python and Google up similar questions about R or about MATLAB, there's just many, many more answers available to you with Python. So this combination of a scripting language where it has a large online community, it makes Python clearly a superior language for data science. And Python is in the midst of sort of a virtuous cycle with respect to data science, in that as more data scientists use Python, the quality of the productivity tools improves and the breadth of the numerical libraries you get to access also improves. So there's a great many libraries for machine learning, for statistical analysis available in Python. So you don't just have to do predictive analytics. You can do all sorts of numerical analytics with Python. And there are tools like IPython or Jupyter Notebooks that are really exciting people in terms of your ability to share your work and to document your interactive sessions, to create graphs that you can share. So these are all key advantages of Python. More recently, the mixed integer programming engine. So mixed integer programming is probably the most common type of prescriptive analytics. And the mixed integer programming engines now offer algebraic modeling. So you don't have to worry about this sort of bookkeeping that involves with setting the coefficients of your constraint matrix. Instead, you can just write out sort of natural algebraic constraints. And the mixed integer programming engines have APIs that recognize how to add a variable to another variable, how to multiply a variable by a constant. They recognize what it means when you say, one thing is equal to another, or one thing is less than equal to another. So you can write out your constraints, or you can write out your objective function in a very natural way. Python really promotes the idea of modularity. So this makes it very easy for you to transition from exploratory programming to creating a small library that can be archived and shared with others. And in particular, and so this is what's called building a package, right? A library in Python is called a package. And it's very easy with packaging to indicate, what are the public functions of the library and what aspects of the library are for the internal black box. Python also makes it very easy to incorporate testing, right? This is a common Python theme that testing should be incorporated into development. And that's particularly advantageous, I think, for predictive analytics, in that you can use the unit test framework, the unit test library that comes with Python to support building test suites. So with predictive analytics engines, it's very nice to be able to, as you extend the engine, as you add functionality, it's very nice to be able to validate that you're not breaking old functionality. It's also nice to distribute an engine along with sample data, and all of those things are easily supported with Python. So let's talk a little bit about prescriptive analytics and what are the challenges there. Prescriptive analytics has been called optimization has been called the best kept secret of IT, and there's a reason for that. It's prescriptive analytics is hard. So in particular, prescriptive analytics requires people to combine these three different skills together: software engineering, mathematics, and business expertise. And these are three difficult tasks that it's not easy for an organization to wrap all three together. So in particular, some of the sort of software engineering tasks that are often glossed over with prescriptive analytics is validating the input. So we see this as an important task that, it's not very sexy. You don't really see a lot or really any good examples out there for how to do it, but it's something you ignore at your peril. So prescriptive analytical engines are somewhat different than machine learning in that when you build like a mixed integer programming engine, you build it to only run on a given schema. And if you try to give it input data that doesn't obey the particular rules of your input schema, you're asking for trouble, right? In the best case, you'll simply throw an exception, and in the worst case, your code might not work correctly. It might quietly give you bad data. So that's why it's important that the data be validated for cleanliness before you run the mixed integer programming, before you run the analytical code itself. And so we see this as sort of a key step that's either ignored or it's done, in a very tedious way. I've talked to people that say, we don't skip that, but what we have to do is every single time we have to write out these, we have to build these SQL queries to look for the common problems. And and that's, you can see why when a task becomes repetitive like that, where it's often neglected. So what Operalytics has done is built a library called TICDAT that's available on PyPy. So in other words, this is an open source library that you can install easily, the same way you install any other Python libraries. You can use the pip install command to install it. And TICDAT fills a void we see in terms of promoting good software development practices with prescriptive analytics. So in particular, TICDAT makes it very easy for you to define the input, to define a schema, and to define validation rules for that schema. So as I said earlier, this is a task that's often ignored, or people that don't ignore it, they have to write a lot of they have to build a lot of repetitious SQL queries. We think that TICDAT provides that functionality in a much easier manner. TICDAT also will save you the trouble of having to understand the details of the file IO libraries. So you don't need to worry about exactly how the XLS library works or the CSV library works. If you define your input schema, then we know what tables and fields you're looking for, and TICDAT can then read from the XLS file or the CSV file. It knows the details of those libraries and spares you the trouble of having to study them. As a bonus, because TICDAT makes it easy for you to read data in any file format, it also makes it easy for you to convert your data from one format to the other. So in doing so, TICDAT promotes building test suites for your engines. So we make it very easy for you to take data from an Excel format, turn it into a human-readable .SQL format, and then your .SQL files can be stored in your repository right alongside your Python testing code. So I walk through sort of the utility of TICDAT in building modular engines. Of course, we did this out of benevolent self-interest. We hope that people who use the TICDAT engine to build more modular prescriptive analytical engines will also be our customers in terms of, if you build your engine with TICDAT, if you use TICDAT to do the file IO, then you will naturally have an engine that's easy to deploy on the Operalytics cloud platform. So TICDAT is sort of two birds with one stone. It is the API that you use to deploy on the cloud platform, but we also think it has a lot of utility just as a standalone engine, just to make your life easier with the file IO, makes your life easier with checking for dirty data before you're running your engine. Okay, I hope you enjoyed this summary of Python and prescriptive analytics. I have some follow-on videos where I go into I go through specific code examples. So everyone likes the diet problem. We have a diet repository on GitHub, and I have a follow-on video where I walk through that code and show you how I've built a modular package with the Diet repository. And similar, I have a modular package for multi-commodity network flow. So hopefully I'll see you there, and thanks for your time.